talking about server-side Swift. You heard something yesterday. So yesterday we had the whole basics about Swift on Linux. We heard about Kitura. We heard about the whole stack of working that stuff. And today I will just build on that and just take it a little bit further and talk about architecture on the server and how to actually build your applications and actually make them work from the hello world and on. So why is server-side Swift awesome? Basically 2 years ago, or almost 2 years ago, there was this guy named Errol Balkan who started a company called Indie. I'm not sure if anyone here ever heard of the Indie project. It was a whole company built around open source software, enabling you to do awesome things. And they had this vision of building all their server-side components in Swift, which was a really crazy idea at that time because Swift wasn't open source. It wasn't announced to be open source. And basically, most developers on the project had no idea what they were doing. But they had the ambition to make it work, and they wrote this open letter to Tim Cook, begging him to make it open source. And a little bit later, they actually just started on their own. They just re-implemented the Swift compiler. They called it Project Phoenix. And I read about it, and I heard it in a talk, and I was totally blown away. So the moment they told me, like, you can use your new favorite language, which is changing every day, on the server and break there as well on your phones. That's awesome. So basically, I was like this. Yeah, we are going. So a little bit later, Swift was announced to be open source. That's kind of interesting. So why not have it open source, work on it, make it actually work on Linux, so we can finally take my favorite language to the server. And so I reacted like this. It's getting awesome. A little bit later, IBM announced that they will actually use it on the server, so there was suddenly a big company behind it. And then Apple pretty much did the thing no one expected. They open sourced Swift on GitHub, and they were telling, we're accepting pull requests. And that was like, oh yeah, hell is freezing over. Apple doing pull requests, this is going to be awesome. Maybe we finally have some stable software from Apple, so yay. Or not. Not really being stable, but we are getting close. So making a short detour and just telling you a little bit about how I look at things and why I look at things that way, or just having a short detour in who this guy here actually is, or AKA the shameless self-promotion part. So my name is JensRavens. I'm a software developer at a company called Nerdgeschoss. Mostly we're building mobile-first websites and apps, mostly iOS, some Android. And we're just working for startups, medium businesses, and really on advanced stuff. So basically everything that most agencies just tell you, this is not going to happen. We can do that. And also, so my job is like 50% iOS, 50% Ruby on Rails, most of the time. And then come those moments where Ruby on Rails is not enough, or where iOS alone is not enough, and then we add more stuff. We add Go on top, we have node.js, we have PHP, and we have actually hundreds of other languages also happening at that company, and we just have this gigantic mess of everything. And I just thought all the time, well, it might be interesting to maybe just unify that on one single language to just make my life as a developer at an agency a lot easier, just to reduce context switches. So also I'm hosting this meetup in Berlin called Swift Berlin. So we're basically a user group for Swift. We are meeting once per month, and currently we have, I think, most meetings are like 100 to 150 people. So it's really taking off in Berlin. People are just amazed to learn about Swift, and actually there's quite a high percentage of people who are amazed by this whole Swift on the server thing. So going back from my perspective to what I'm actually going to talk about. The first thing today is, well, why Swift on the server might actually be a good idea, apart from breaking every other day. A short introduction to HTTP, the internet, and everything else. How hard can that be? Also, abstracting server implementations from request handling. So yesterday we saw this basic Hello World applications, but if we want to scale from there, we just have to build some abstractions in there. And in the end about model views, controllers, routers, and storages, you might find some references to other talks here. And so as a closing note, the current state of server-side Swift and where we are going from here. So let's just get starting. Why Swift on the server might actually be a good idea. That's first a kind of interesting question because there is pretty much no ecosystem around server-side Swift yet. Everything is kind of in development. The Swift package manager is not yet there completely. Half of foundation is still missing, but we are getting close, so let's see where this goes. But one of the main reasons I constantly hear is speed. Swift is fast, well, we all know that. It's comparable to most compiled languages, and it's pretty freaking fast if you do a good job. But one thing that I constantly miss when people talk about server-side Swift is actually developer happiness. Or in my case, something like this. So people tend to just talk about raw performance on metal. That might be an interesting thing. We talk about that a little bit more. But one thing that we always should keep in mind is developer happiness while developing. Because basically you're spending your whole day in front of this machine, typing in things. I have no idea what I'm doing, but somehow it has to work. So developer happiness is a really big part, and also developer productiveness. So if a developer is more productive, you can just earn more money in less time, and everyone will be happy, even the business guys. So going back to point number one, the raw performance. So I think that was published 2 days ago by a guy called Ryan Collins, and he did a benchmark between different server frameworks. This is kind of opinionated, so it was a basic blog page, so static HTML with some dynamic content in there. But basically you will see that Swift is somewhere around the performance of Node. That's kind of the thing we can read from here. We have different server implementations in Swift. Depending on what you're doing, different servers will be faster or slower. I just recommend you read the article on Medium. But basically what we learn from there, Swift is pretty much screaming fast. So if it's screaming fast, it basically gives you more bang for the buck. We heard about that yesterday. It's really important to talk about memory per hour. That's kind of the currency in the web you think for. But here's some small secret from my perspective, and that is, I don't care. Basically, let's just take a look at last month's spendings of my company. Last month's spendings were 87% on salaries and 2% on server costs. Basically, it's 1.4 something, but it's just rounded up by Keynote. So basically, server costs for my kind of company, and I guess for most smaller to medium-sized company, is usually not really an issue. An issue if you do software development is actually the development time, the people that are working for you because they get a freaking high salary. Especially in Germany, if you just add all the social insurances on top, it gets really expensive, so 87% is just salaries. So basically that means faster development equals more revenue, and more revenue makes me happy and makes the developers happy because I can pay them. So one thing I want to keep you in mind during the next few minutes is Swift is basically fast enough. I don't care that much about more performance. What I really care about is developer productivity. And that's something I really would like to keep all framework authors for the future awesome Swift frameworks that are coming in their minds is, please make me more productive. Swift is just fast enough. We can do more performance later on, that's fine. I'm happy to save some bucks on the server, but basically I would rather love to save some developer time. So, going back from the whole motivation to actually some technical details. Short poll of hands, who has ever done some server-side development? Oh, that's quite a lot, so I can skip, or I can just skim through it. Basically what I'm going to tell you is how actually requests are routed through the whole web, and basically from an iOS developer's perspective, I often hear people who have actually not really an idea how the internet works. It's more like, yeah, this is this magic black box, and there's some magical black thing called the internet on a table somewhere, and we call it a server, and it's a magical device which is just doing something. So let's just do a short recap on actually what happens if you type something in the address. Basically, the first thing you will see if you just type something in your browser and want to get a website is you want to find out where that server actually is. And so you talk to a DNS server, and the DNS server tells you, oh yeah, here, this is the IP here, there you can actually find your server. Please give it a call. So next step from there would be send a request. A request is basically just a text file. It's just some plain text over TCP. You tell the server what you want, slash, so basically the root of the thing, what protocol you're going to talk, HTTP 1.1, which is around with us for pretty much always. HTTP 2 will still need some years until we actually have that in most server implementations. You tell the server for what host you actually want something, and you tell the server, I accept everything. Just give me something, I want to display something. So you actually talk to that server, you open a TCP connection, you send over that request, and the server will give it to some kind of load balancing if you're using Heroku, if you're using Amazon Elastic Beanstalk, or whatever there is, maybe just Nginx. That load balancer will then just distribute it to different app processors, and those app processors then just answer with some plain text. Again, we have a header. The header and the body is just separated by 2 empty lines. That's kind of basic formatting in there. And it's telling you, yeah, you wanted something. Here I have some HTML for you. Maybe that's good. And here's your HTML. So just display it. So if you think right now, well, this is just some plain text over TCP. I can do that too. Basically, yep, you're right. It's just some plain text over TCP. So if we want to abstract that a little bit and just formalize it in protocols in Swift, our requests would look something like this. Just ignore the first line, we come to it a little bit later. So we have this method, we tell the server like we want to get something, we want to post something, we want to patch something. We give it some parameters, usually from the URL. We have some headers, we have a format like JSON or HTML. We have some kind of body. The body might not be completely there yet because it's still transmitting, so let's just call it streamable. And we have a path we actually want to get. The whole context thing is you can just add more stuff in between later on. So maybe the load balancer is adding something that you want to know of. So context is pretty much just a big bag of things you can throw in and get out there later. So once the server gets a request, well, just give it a response. The response to the browser is pretty much just 3 things. We have, again, headers. We have a status code. Well, you could do that in the headers, but it's just so common to restrict it a little bit. And then you tell the browser what you're actually sending him. So let's, again, call it a streamable, because maybe it's a big file and we just stream it out there. And a streamable is just something that just sends out chunks of data. So basically you call it again and again and again until it someday just tells, oh yeah, that's it, streaming is over, here's your file. The cool thing about this abstraction, which is I think also done by several frameworks, is that it actually can even handle long pollings, so event-based things. It can handle event sources. And basically via the streamable protocol, you can even emulate WebSockets. So basically, we do not care about transport. We only care about the content of the request. And that actually makes this whole abstraction kind of interesting. So isn't this the same for every app on every single web server in any language? And yep, you're right. This is just the same every single time. So why should we re-implement it? And that's why we actually should abstract this. Abstracting the server implementation, so taking this whole TCP stream and handling multiple connections and handling all those devices, is pretty much common between apps. And on the other side, there's our special app logic. This is the thing that is special to our app. Why should we care about this whole TCP handling? And that's why we have web frameworks. One thing to keep in mind here is that it would be really nice to actually have a common abstraction between web frameworks. So if we think about Ruby, for example, on Ruby there's this cool thing called rec. Rec is kind of an interface, so it's kind of just a single protocol, which is stating how a server and the application are interacting. So it's basically just defining request response and how an application works. So it's 3 interfaces. And that was so successful that is actually used in the whole Ruby community. So no matter if you're using Sinatra or Ruby on Rails or whatever kind of framework, you can switch out the server. So you can combine one server with one framework, and then you decide which frameworks to combine, and they just communicate via the same common interface. There is something similar going on for Swift right now. The first thing was Nest, which kind of looks abandoned right now. I'm not that sure about it. I haven't heard a lot of it recently. But there's also a project called the Open Swift Standards. So Open Swift Standards is a library of protocols which are mostly formally describing different concepts. So there's, for example, the C4 things. No, it's called the S4 protocols, which abstract everything around server development. So they propose how a request looks like, how a response looks like, and what methods they have in common. So if you have a server and a framework that both agree on Open Swift standards, you can just combine them. There's also, I think that's the C7 proposals, that's about common data types. So how does data look like, how does JSON deserializing work? So they just agree on common protocols, and if just both parties agree, you can mix and match libraries on same data types. Okay, so talking about this whole abstraction thing, how does it actually work? Basically, you have the internets, whatever that is, which is just pumping out TCP connections, all different kinds. So from HTTP 1 to HTTP 2 to Websockets to all different kinds of data communication. Maybe you just send something by letter. We don't care, we just have to transmit some data somewhere. Then we have our generic server implementation, which is taking that data and transforming it via the standard to your next awesome killer app. So you can just switch out any server implementation. You can start with Kitura, then recognize, yeah, maybe I want to focus a little bit more on WebSockets, so you switch to Savo. Then you realize that Savo is just really slow at compiling. Then you switch over to the next one, and basically it's not a problem because you can just switch it out. Okay, so talking about the abstraction, now actually just show me some code. People ask me a lot to actually show code on stage, so let's talk about some structure. And there is this really nice concept from yesterday that I just wanted to structure this whole thing around, and let's just call it MVC-RS. Basically because I really like the whole MVC structure from iOS. And if you do not get those massive view controllers, we can actually do some awesome structuring. So let's just do the whole MVC dance and look at how we can actually structure a web application. If you've done any Ruby on Rails, this should seem familiar to you. So the first thing we're gonna define is a controller. A controller is basically just a function that takes a request and then puts out some kind of response. The real trick here is actually to make it throwing, so we can have some generic error handling there. So one thing you will find on server development is that there are hundreds of things that can go wrong. And usually there's not really a common way to solve everything. So you have those last line of defense in front of the web server, which is just taking that error, make a 500 page and just returns the request. But basically you will have error handling at different levels of your abstraction. So maybe you are looking for a record in your database to find out that we do not have that record anymore, it's gone or it's never created or someone is hacking into the system. So you can just throw errors at different levels and they just bubble up until someone takes care. And if no one takes care on the last level, we just make a 500 page out of it. So how does such a controller look like? Well, basically you get a request in and you return a response. The response, again, we have some status code, 200, everything's okay, here's your website. We have some headers, or we don't. And we have some content. So string is basically just a chunk of data, so we can just stream it out. So here's our content, and we actually have our very first web application. Yay! Okay, so printing hello world as a plain text files might look a little bit boring. So let's spice it up a little bit. And here we go to rendering views. Views are awesome. We can show things, we can make them pretty, and basically we can just boil it down to some basic things. A view is something that you instantiate with some data, so it has some kind of init, but that's up to you. And then you can call render on it. Rendering a view will just make whatever format you're going to return. That might be JSON, that might be HTML, but in the end you have some streamable content. And because it's so common, let's just implement a second one which will return a response instead. So it will render that thing and then just return a 200 and everything's okay. And just to make it a little bit more abstract, also make it return some kind of format. So maybe one view is rendering your JSON API, another view might be handling your SOAP Microsoft interaction thingy for legacy reasons, or it's sending some code via email, whatever kind of transaction you have. So basically you can have different views for different ways of rendering your data, and the whole rendering thing is abstracted in a view model. Great. So just have an example for here. Let's talk about JSON. JSON is awesome, everyone likes JSON, and especially parsing JSON, at least if we think about the stars count on GitHub, where I think we have more than 150 JSON parsing libraries by now. So let's just do something that takes any object and turns it into JSON. So we have an initializer, we save that object for a little bit later, and when we call render on it, we just serialize this whole thing, make it pretty printed so we can actually readable, so it's to streamable, and just do some basic protocol extensions to just implement the other one from render to request, because that's just 200 and status and content type JSON, so you can just infer it from there. And basically, we have a generic JSON render, so we can just put in something, return that renderer, and our application suddenly speaks JSON. Not that hard. Okay, so moving on, next one's models and persistence. So talking about the next awesome block you're going to do, let's just do a block application as a hello world thing. Let's think we have some posts. A post has an idea, it has a title, it has some content in there, basically just some strings, and that's it. What you see here is post is not inheriting from anything. It's just a struct. Can save some data. What we have next is called a repository, the storage part. Basically, if you've ever looked a little bit deeper into database abstraction, usually there are two big things. One is the active record thing. So that's a pattern where each object represents a row in a table, and you just give it business logic on top, which usually means that you have to inherit from some object and have to do some really strange things, and it's really hard to actually have private and public things because so much things have to be inferred. That's why I usually prefer the repository pattern. So storage and models are different things, basically just as in yesterday's talk. A repository can be some repository of some element, for example a post. You can call find on it to find something by ID, and you can do some kind of query. So give me all posts that were posted before yesterday and that have more than 60 characters in the title. Basically everything you can do in SQL can be done in there. And how does it work in the end? Well, you just ask your posts repository to find some post from your request parents, get all the attributes out of there, and then return your JSON view. And basically, this would be the whole application to render your block as JSON. And basically, it would also be pretty much the same code if you want to render that as HTML, because you just switch that out from JSON view to your post HTML view. Because the whole rendering logic is moved to the HTML, the controller doesn't know about rendering, it just knows there is some object that will do the rendering for you. Okay, so we have the whole MVC stuff, we have the storage. Let's move on to the last part, and that is, right now we have this one controller rendering one page, which might get a little bit boring over time. Maybe you want to have more than one page, so let's meet the router. Our router thing has basically ways to register new routes to it. So for example, we can do GET requests, POST requests, PETCH requests. You give it a path and some kind of controller generating function, which might look like this. So again, we have our controller, we have some JSON thing, we have some parameters in there. So next one there. So we have this router, it has a GET request for messages/ID. The ID is parsed out of the root, it's put into the params hash, and then you can do something with it. For example, asking your repository to give you some post. And in the end, you have this router thing, and just serve it. So here is actually the interesting part, the serve function. The serve function is whatever your framework is giving you. So here again, we have this open Swift standards thing of having a common base class, or having a common protocol. And basically, as long as the server and your app agree on each other, this function call works. An interesting fact here is that you can actually usually transform between different applications. So if they do not agree on the same standard, usually they all agree on this request-response cycle in different ways. So usually, if they do not agree on the protocol, you can at least do some wrapper around it and it still works. That's at least what I've been doing at my job so far. So you can just take your favorite server and write your stuff on top. So reviewing this whole thing. Basically, we have some kind of database. That might be Postgres, that might be Elasticsearch, that might be Mongo, whatever you prefer. We maybe have some external web services that we also agree on. Everything here is wrapped in repositories. Repositories can do SQL queries for you, they can access the file system, they can access external web services. Everything for kind of external non-application data is accessed through a repository. Those repositories are called by controllers, and those controllers interact with models and views. Maybe you have more than one controller, and those controllers are coordinated by routers. Basically, that's what we've talked about so far. So some minor observations. One thing, routers are actually controllers because they take a request, they give a response, that's what a controller is doing, which also means you can start to nest routers. Nesting routers means you can have like a base application router, then this one is handing over to a JSON API to handle JSON requests, and another router is taking care of your web application, and a third router is rendering your web views for your Cordova app or whatever you're doing. So basically you can nest routers, you can have modules. You can actually put those modules into Swift frameworks and then just have a common router to bring it all together. So nesting routers is a very, very powerful concept, and that's basically possible because it's just a controller. That also means you can start to nest controllers, because you can just hand in one controller to another one, and we talk about that in a minute. Next one, models do not inherit from anything. Models are your domain logic, and if you want to share your models between different applications, and sometimes it's actually possible to share iOS app models with server-side models. We do that in one application. That actually works. It is somehow tricky to actually do the models in a way that this works, but if you put some mind in there, it's actually working. So your models do not inherit from anything. They do nothing unexpected. You can decide if you want to use value types or whatever. You can write your own code data on the server if you like. But basically, models are just really dumb things. Next ones, controllers can call other controllers, and that's a concept we call middleware. Because a middleware is something that is between something that is calling your server and that is actually responding, and it can modify the request. So this controller gets a request, it can modify it. So for example, it finds out that, well, maybe we cannot handle JSON, but we have JSON plus HAL. So let's just modify the request and make it better. Maybe we want to actually alter the response after it has been generated to inject something into the HTML. So maybe Google Analytics middleware. You have your application, it renders your application, and in the end, there's something which is just injecting your Google Analytics code before the closing tag. You can do all this stuff with middlewares. One powerful feature that, for example, Ruby is using in middlewares is authentication, because usually your whole application is authenticated. So if any kind of authorization header is set, it will already add the current user as a property on the request. And that's why we had this very first line on the request, this bag of data where you can add anything. That is actually just for this exact reason, that you can add more stuff on the request and just add more content that you can access later. And the last one, and that is client and server architecture are actually pretty close to each other. We have models, we have views, we have controllers. And if you think about this way of controllers, you can actually even implement that client side. Here's kind of some advertising for another talk. If you're interested in this whole client-side request thing, there's a talk called Hipster-Oriented Programming from last year, where I just get into some details about how to treat the user as a function to generate data for you. So you can actually start, or at least think about, code sharing path over there. So having your server and your application maybe even in the same repository. Okay, so far for the code part. Let's move on to the last thing, and that is the current state of server-side Swift. This is a big not yet there. Almost, not yet completely. So we have some application servers. We have some ideas like the Open Swift standards, which, at least in my opinion, are a little bit too complicated. We have actually hundreds of frameworks popping up everywhere, so let's just see which one will be the big successor in the end. But basically, the whole community is just really getting started right now. Everyone is waiting for Swift 3 to finally have the package manager, because that's kind of the moment everyone is waiting for to finally get started. But I think we will really see an explosion in server-side Swift within at least half a year. Swift is really fast. It's nice to develop with it. Basically, you can use some tools from your client-side development while we are waiting for better ones for the server. So as we've seen yesterday, you can just generate a code or an Xcode project from your application and just develop in there. So you have code completion, you have documentation. We actually have this whole idea about Swift coding guidelines. So the language is, although we are constantly making fun of it in the last 2 days, it is actually pretty advanced, and we have some basic idea where it's going. So we can really start building stuff on top of it. So that's kind of the current state. We are almost there. Just wait 2 weeks or when we will have when we have Swift 3, and I guess then really we will see an explosion in this whole topic. Especially because, in my opinion, it really hits the sweet spot between developer productivity and actually performance. Coming to my personal wish list, things I really would like to see in the whole server economy, maybe with regards to IBM, maybe someone's watching here. One thing I really, really wish for as being a part-time Rails developer is a Swift framework that is totally configurable, like the thing that we have now, but like this batteries included thing. I can switch out things if I want to, but just give me some common defaults which makes development a lot faster. Because what I do as an agency owner is we have to build products in a really short time for usually some restricted budget. So we do not have time to set up 2 days of configuration files in some Swift project. Just give me some good defaults which are good for 90% of the case and just make me work faster. And if I want to go further from there, make it possible, but please give me some defaults. One thing, also coming from the Rails perspective, be explicit. Please do not surprise me by doing something in third, but also don't be too verbose. Please do not do node.js again. That just takes too much time for me. Also, I would like to have more projects conforming to this whole Open Swift standards. Currently, I think there are bindings for the Nest protocol, and there's also, I think, Vapor is also doing the Open Swift standards. Kitura, not yet, correct me if I'm wrong. But that would be really awesome for me to just pick one server, get started, program my application, and then later on pick the server that is best for my performance. So maybe I just want to do more WebSockets, maybe I need more concurrent connections, maybe I just need faster response time. It really depends on my use case, so please make it easy for me to switch out the server if I do not want it anymore. And one last advice is please just do not imitate other frameworks. Do not imitate Express, do not imitate Rails, because they are built for their language. We have a really awesome language, and if we just imitate Express, we are just losing so much. We have this whole type-safe thing here. There's nothing cooler than just using Xcode and have code completion, and if the compiler tells you your application is compiling, I really would like to just know, well, if it's compiling, it should be 99% correct most of the time. So basically, that's it, and thank you.
All right. All right. So, do we have questions? I'm guessing probably going to have some questions. Otherwise, I will start as usual. Think about the questions. All right, cool. You can start, actually.
Thanks for the great talk. Regarding the open Swift standards, are there any efforts to support a more reactive programming model, to have non-blocking and reactive engine underneath?
Basically, these are two different topics. So for the reactive programming, that's more like kind of an implementation detail of the server. And there's so many different ways of how to handle requests. You can do multi-threading, you can use GCD, you can use an event model like Node. And I guess for every single idea, there's already a Swift server out there doing this exact implementation. But in the end, it really just comes down to request to response. There's some discussion going on there between two different ways of giving that response. One is doing it synchronous, the other one asynchronous. I think this open Swift standards are for the synchronous model. But basically, I think there's also a second thing going on there, but I'm not completely sure about that. But usually I really prefer the synchronous thing, going back to this whole developer productivity, because you just cannot forget to return something. And that's, although you think that might never happen, it happens all the time.
Thank you.
Another question? Oh, my mic is left the building. Yeah, another question? I'm gonna ask one and think about. So you are just right in the middle of like Cocoa developer and Rails developer. This is also where I was a couple of years ago, and many people are there. Do you see like the Rails community being excited about the Swift on the server?
My current responses so far were, what Swift? So I guess not really.
So they're not even into looking at the language, that's what you mean?
At least that's my experience so far. What they're really excited about right now is Rust, because they just implemented Rust bindings into the Ruby language. So they're trying to rip out all the C stuff and replace it by Rust, but that will take some time. But basically, I haven't heard a single Rails developer so far talking about Swift.
So it's good that I hear this, because there's also still Ruby Motion, and there's still some decent sized Ruby Motion community, like living on their side of the world, so to say. It's interesting. Rust, can you just give like a little pitch on what it is, because I haven't followed this?
Well, Rust, I think it was considered as a replacement for C. So actually it's kind of similar to Swift. So you have all this type inference thing, you have memory safety. So it was really considered to be a safe and fast C replacement. So kind of Swift without the overhead. And it really was meant to write system libraries in there. So from operating systems to security things, to never have this poodle attack and heartbleed and whatever again by having too many break statements. So the basic idea is kind of similar to Swift, but it really was written with high performance in mind.
Okay. All right, go ahead.
One question about development. What is the best practice to write Swift maybe on a cross-platform basis? Are the developers going to use their own IDEs on Linux, for example, or are they actually using Xcode? having to buy a Mac? What is it working out?
So basically, there's app code out there. I'm not sure if they have
What
a
is
Linux
app code?
version.
IDE?
So app code is
Okay,
kind of an
thank you.
Xcode replacement. It's based on JetBrains IntelliJ.
Yep.
I'm not sure if there's a Linux port yet, but also there are plugins for Sublime Text and Atom. So if you're just more of the boiled down non-IDE guy having a nice text editor, you have Atom and Sublime. Both have really good Swift plugins, actually. That's usually what I use for source code formatting on my slides. I just copy them from
but
app code.
are they used or are the developers developing on Macs?
So app code is, I'm not sure if app code is on Linux, but
I don't think it
no.
is, right? It's not. Yeah, I see
Yeah, but
everybody.
Basically, it's Mac.
Okay.
But
It's only
there's
on
not
Mac.
really a reason it shouldn't be on Linux. It's just like there is no IDE yet.
I have the. I'm afraid that we could have completely different project files, for example, in different platforms.
Basically, you can just
that will give us a big hurdle to communicate.
That shouldn't
some
be a
way.
problem because the whole configuration lives in your Swift.package in your package.swift, and that's cross-platform. You can generate an Xcode project, but you can just delete it at any time and regenerate
Yeah,
it.
but that's the minimum. Actually, we are talking about project files, which are much larger than just only about Swift. It's about resources, all those things. And we have the Xcode project files, and they are not comparable to other project files. And Apple doesn't even document on the inside of the project files. They are XML. You can read them, but don't touch them. It's
but
really
basically,
really hot
Xcode
stuff.
project here is really just a nice layer on top. You can just rip it off, and it still works.
Yeah, but in practice, we have to have some common denominator
And
to
that's
get
the Swift package.
cross-platform, and this is a big hurdle. Not
So
making
so
it
far, I
happen.
didn't have any problems because we have one Linux developer on our team, and he was totally fine with it
Okay.
without
It's
using Xcode.
Even with repositories like Git and so on, it works fine.
Sorry?
With repositories, concurrent development, it works fine.
Yeah.
Okay.
All right, we're gonna stop with the question because we're gonna have a break, and also because you can ask questions during the breaks. That's why you guys have a ticket compared to the people watching the videos, who will have a ticket next year. And yeah, thanks Jens. Round of applause for an amazing talk. And
By the way, all slides are on the website in 5 minutes or so.
Okay. And I guarantee there's going to be at least one talk about server-side Swift next year at SwiftConf. All right, go outside and use the sun because we paid for this. Like 15 minutes or something.